Welcome to our project. Our project is design and development of high-efficiency heat sink for improved thermal management. Our supervisor is Dr. Barkat Ula and the team members are Muhammad Ikram, Muhammad Rehan, Sheraz Ali, Usama Zahor. The introduction of our project is a heat sink is a heat exchanger that transfers the heat generated by an electronic device to dissipate from the device. In computers, heat sinks are used to cool CPUs and GPUs. To overcome overheating, fins are used, fins having a large surface area for enhancement of convection heat transfer. Many modifications have been made to the geometry of fins, like cavities, slots, holes, grooves, and microchannels. Such modifications in geometry provide more surface area for convection heat transfer. The problem faced by heat sinks is commercial heat transfer faces a challenge due to a design flaw, causing slower dissipation of heat. Lack of heat transfer through the heat sink leads to the system overheating and getting stuck. This issue reduces its overall lifespan. We used SolidWorks to design a model of the heat sink. The first one is a plain plate fin heat sink, and the second one is the novel plate fin heat sink. The plain plate fin heat sink is a simple heat sink, but the novel plate fin heat sink integrated by semicircles and slots for enhancing the area of contact. In the simulation we used ANSYS software to simulate our model, which we designed on SolidWorks. We used ANSYS to analyze our model under boundary conditions to find the results for further processes. We used CFD Fluent to analyze the heat flow and the behavior of our model, and we found the following results. This is our model, which we fabricated with wire cut machine, and we also performed experiments on this model to get our desired results. This is our testing module on which we have performed the experiment on our fabricated model to determine the results of our project. In project details we will how performed and also the components of testing module. In the testing module, we have an airflow channel where we mounted a heat sink, and the heat sink base is attached to the heater and flow channel inlet mounted with a fan and inlet temperature sensor. In flow channel, there is also an anemometer which determines the airflow velocity and outlet of the channel integrated with a thermocouple sensor. Here is the display of our readings.